Hello, Mr. Wakefield here again, and we're going to be looking at dividing polynomials now, which is the natural next thing that we would do since we previously covered adding and subtracting polynomials, and then we covered multiplying polynomials. So dividing polynomials is the next step, and that's this is section 6.4. So the key thing to remember, first of all, before I jump into this is there's two different types of problems here, and we need to make sure that we use the correct method for the correct problem. When we divide a polynomial by a single term, in other words, a monomial, that's one type of problem. And you can see these problems down here. See how you've got a bracket divided by a bracket, which again, because the brackets are there, that means that this entire first bracket is being divided by the entire second one. So you're dividing by a single term right here. You're dividing an entire bracket here by the other bracket, which again is a single term. So you're dividing by a single term. Okay, remember when they say dividing by something, it's that second thing that you're dividing by. Okay, you're dividing into the first one, but you're dividing by the second one. And so same thing down here. All right, the fraction bar again means division. So when you have a fraction bar like this, it means you're dividing the entire top part, which we call the numerator, by the denominator, the bottom here, in other words, and you can see it's a single term. So you're dividing by a single term. Same thing over here, dividing by a single term. So whereas on the back, okay, or the second page of this section 6.4, you can see that in each case here we're dividing by a binomial, two terms. Okay, we're dividing by this, we're dividing by 3y plus 2, 2y plus 1, and 4t plus 3. Okay, that's a whole different problem because you're dividing by two terms instead of one. So please remember that as we go through this. All right, when you divide by one term, the method is different than when you divide by two. Okay. Very important that we get that right. Another thing I want to make sure we understand here, not that we've even talked about this yet, but we will coming up soon, so I just don't want you to get confused. Okay, our answers here must have positive exponents only. I've seen students have negative exponents, and that's not the way we want to do it. Okay, positive exponents only in the answer. Okay, not that negative exponents are invalid in some kind of way. It's just not the best way to write the answer, so that's not the way we're going to write the answer. Okay, but if you just do it the way I show you to do it, then you'll be fine. You won't get any negative exponents. Okay. All right, so let's jump right into it. When you divide a bracket times a bracket, again, when it says bracket divided by bracket, it means that you're dividing. And you don't have to write it this way, but a lot of students prefer this. You are dividing the entire first bracket by the entire second one. And so I just like to write it as a fraction like this, just to see it better, okay? Just to make it easier to visualize what's really going on. Yeah, when you got a big fraction bar like that, it means the entire top divided by the entire bottom. And when you have a bracket divided by bracket, it's that same thing where the bracket is the top and the other bracket's on the bottom. But what do we do, though, with that? Okay, that's not the answer, certainly. What we do, and let me give myself some space here. Okay, we're going to need a couple more lines here. Is when you have the thing that you're dividing into, the first part before the division symbol, if that's got more than one term, but then again, like I said, when you're dividing by just a single term, that means it's kind of like when we did multiplication in the previous section where you distributed the single term to all these terms here. It's the same idea where you distribute the single term that you're dividing by, you distribute that to each one of the terms that you're dividing into. Okay, but we got to be a little bit more careful about how we do it, though, this time. Okay, because see, here's the problem. The 7m to the third does not divide evenly into all of these terms that are over here in this first bracket. Okay, or on the top of the fraction if you prefer to look at it that way, like I do. It doesn't divide evenly in all those, but we do have to divide or distribute and divide into each one of these three terms. So because it doesn't necessarily divide evenly, what we need to do to make sure that we do it correctly, and also sometimes it may not give you positive exponents either, okay, if you just try to divide it real quick without doing what I'm about to show you. So if you do what I'm about to show you, you'll be fine. What you do is, since there's three terms separated by plus and minus here, inside of the first bracket or on the top of the fraction, same thing, that means that we're going to do three divisions. So what we're going to do is we're going to set it up as three separate fractions like this. 56m to the 6th divided by 7m to the 3rd. Okay, 4m to the 5th divided by 7m to the 3rd. And yes, we'll have some signs in between the fractions here as well. I'll get those in there in a minute. And finally, 21m squared. Yes, I'll account for that minus sign. I'm not forgetting about that. Divided by 7m to the 3rd. Okay, so since there's three terms, we need to do three divisions. Okay, now here, what about the signs? All right, we got to account for those as well. And that works in a similar way as the multiplication as well. Okay, if it's negative, then you put a minus in front of the term. If it's positive, you put a plus in front of the term, unless it's the first term. Okay, like we talked about, if it's the first term and it's positive, then you don't need to say anything in front. We're going to do that exact same thing here. Okay, positive divided by positive, you can see this is positive 56 and positive 7, right? So positive divided by positive is positive. So since this first fraction is supposed to be positive, I don't need to put anything in front of it. Okay, you could put a plus there if you want, like I said before, when it's the first thing, but you don't have to when it's positive. The next one is positive 4 divided by positive 7, so that's positive. And so for that reason, I need to put since it's not the first fraction, I need to put a plus there. Just like I did when I was multiplying. You put a plus if it's positive in front. Okay. And then here I've got negative 21 divided by positive 7, so that's a negative answer. Because as we know, negative divided by positive is always negative. Just like positive divided by positive is always positive. Okay. You don't need to actually do the division yet. I'll talk about that here. I know you're thinking, hey, 21 divided by 7, that's equal to 3. Okay, but no, we don't do that yet. I'm just trying to figure out what the sign of each one of these things is right now. Okay, so when you do that, though, when you figure out what the signs are in front of each fraction, do not put any negative signs inside of the fractions. Okay, there's multiple ways to do the signs in these problems here as far as where to put them and everything. Okay, but the way that I do it, which I think is the easiest way, means that you cannot put any negative signs inside of the fractions. Okay, you just need to simply figure out the sign of the answer and then put either a plus or minus in front of each fraction based on that. Okay, and that's the idea, just like we did with multiplication. Okay, so now we've set up the problem. We got one more step to go. All right, I'll put it down here, okay, and give us enough room here. But here's what I'm going to do. I'm going to take each fraction, I'm going to put it in lowest terms, all right? If you don't remember how to do lowest terms, let me explain that right now. But first thing I need to mention, though, is that do not do any canceling, because we're going to be doing canceling here in a second. Do not do any canceling between the top and the bottom of the fraction unless there is only a single term in both the top and the bottom of the fraction. Okay, notice that up here there's three terms on top of this big fraction. Do not cancel when there's more than one term on either the top or the bottom. So since there's three terms here, don't start canceling stuff. Don't start trying to put it in lowest terms. But when you split it up into three separate fractions, then then all three fractions have just a single term on the top and bottom. In that case, it's okay to cancel. One other thing I want to mention is don't try to cross-cancel here. As we'll learn later, you're only allowed to cross-cancel when you're multiplying fractions. These fractions are not being multiplied. They're being added and subtracted, as you can see here. Okay. One other thing I want to mention, just to make sure, extra sure that there's no confusion. We'll learn more about this later, but there are times when you can cancel when there's more than one term on the top or bottom, but that involves something that we're not going to do here, and so we can't do it here. And so that's why I'm saying don't cancel unless you have just a single term on the top and bottom of your fraction. So I can cancel inside of this fraction, okay, and inside of each of these other two as well, because they both have, all three of these fractions have just a single term on the top and bottom, okay. Just don't cancel up here where you got three terms on the top. All right, so let's get started here. How do we put a fraction in lowest terms? How does the canceling allow us to do that? What you do is you start out with the coefficients and you divide them both by common, we call them common factors. We'll get into that more later. But those are the numbers that divide into both 56 and 7. Okay, and you keep on doing that until you can't do it anymore. So is there a number besides 1? Because 1, if you divide by 1, that's not going to make it into lower terms. It'll just keep it the same. Besides 1, what can you divide by 56 and by 7, both of those numbers? You can divide both of these by 7, can't you? Okay, and so if I divide both of those numbers by 7, I get 8, which I'll put up here, and 1 I'll put down here. It replaces those numbers since they got divided. Okay, I'm not doing the top divided by the bottom, you guys. That's not what I'm doing. I know it looks like that. But what I am doing is I'm doing both of these two numbers, 56 and 7, separately, and I'm dividing them both separately by 7. 56 divided by 7 is 8. 7 divided by 7 is 1. Okay. Then when you get to the and by the way, I'm done with the 8 and the 1. You got to double check to make sure. If the only number you can divide evenly into the two numbers you have left over is 1, if 1 is the only number that works, okay, then that means it's in lowest terms. Because if you divide by 1, it ain't going to get it any lower, and 1 is the only number that works, and so it must be in lowest terms, the 8 and the 1. Then what we do with the variable parts is if the variables are the same, okay, if the variables are the same, and don't do this unless they are, but if the variables are the same, what you do is, again, you keep them separate, the M6 and M3, you keep them separate, and you subtract the smaller of the two exponents from each one. You can see here that 6 and 3, the smaller exponent is 3, right? Okay, the smaller exponent is not always going to be on the bottom, by the way, like you can see over here. But whichever one is smaller, you go 6 minus 3 and 3 minus 3. In other words, you subtract the smaller exponent, which is 3, from the exponents that you currently have. 6 minus 3, 3 minus 3. So what does that become? 6 minus 3 becomes 3, and so that's going to become m to the third. The m stays there. It's just the exponent that changes. Here, 3 minus 3 is 0. Now, what is m to the 0, though? Okay, as we'll talk about more later, anything to the 0 power is equal to 1. Not 0, it's equal to 1. And so m to the 0 is going to become 1 right there. All right, and so what do we end up with here? We end up with, what you do is you take the things that replace the old parts right here and you multiply them together, because the old parts, the 56 and the M6, they were multiplied together. So the replacements, which are 8 and M3, they get multiplied also. So 8 times m to the third is 8m to the third. Okay, and then 1 times 1 is 1. But do I need to write the 1 when it's the denominator? No, I don't, because when you divide something by 1, let me just pick a random number up here. Let's say I had 6 and I divided it by 1. Do I need to write that 1 right there when I'm dividing by 1? No, I don't, because I could just write 6, in other words, because when you divide something by 1, it's just going to be equal to the top automatically. And so let me make this a little bit bigger here to make it look like it's the whole first part of the answer. 8m to the third. And let's try that again now. Let's bring the plus sign down and let's try it again. Is there a common number besides 1 that I could divide by 4 and, divide into 4 and divide into 7? No, there's not. And so that means that 4 and 7 are already in lowest terms. But you got to try. All right, and since it is in lowest terms, you leave the 4 and the 7 alone. Keep them the way they are. And then again, you pick the smallest exponent here between 5 and 3. 3 is a smaller one, and so what do? We do 5 minus 3 and 3 minus 3. Okay, in other words, you take the current exponent minus the smaller exponent on both of them. Okay, you are not, again, just like what I said with 56 and 7, you are not doing the top minus the bottom. That is not what you're doing. You are doing you're doing two separate subtractions here, 5 minus 3 and 3 minus 3. Okay, so what do we get? M to the second, because 5 minus 3 is 2. And then down here we got 3 minus 3 is 0. But as we learned, m to the 0 is 1. Okay, so let's take a look at what we got now. The m5 got replaced by m2, so now I have 4 times m squared, which is 4m squared. And then on the bottom I have 7 times 1 because the m3 got replaced by 1. 7 times 1 is 7. Now the 7 I have to keep. I can't just erase that like I did with the 1 on the bottom over here because it's not 1 in this time, it's 7. Okay? You have to keep the denominator unless the denominator is equal to 1. If it's equal to anything else, then you can't just discard it and get rid of it. Okay? Bring down the minus sign. We got one more to do. 21 and 7. What's a common number that divides into 21 and 7? 7, right? Okay. So 21 divided by 7 is 3. 7 divided by 7 is 1. Is there any other numbers now, as you look at your two brand new numbers here, 3 and 1, is there any other numbers that divide evenly into 3 and 1 besides 1? Okay, any other common numbers? No, there's not. 1 is the only common number that divides into both 1 and 3. And since 1 isn't going to make it any lower, the 3 and the 1 are in lowest terms already. Now, what's the smaller exponent here between 2 and 3? It's going to be 2. So what we do is we go 2 minus 2 and 3 minus 2. What do we get? 2 minus 2 is going to be m to the 0. But anything to the 0 power is 1. So I'll put a 1 there. 3 minus 2 is going to be m to the first. So I could just say m. You could say m to the first if you want, but you could just say m also. Remember, when the exponent is 1, you don't have to write the 1. So what do I got left here? 3 times 1 is what's left on the top, which is 3. And on the bottom, I have 1 times m, which is m. And that's it. Okay, so let's review here. This is an optional step where you make it into a fraction, a big fraction. You can keep it as the brackets like this, but you do need to do this step right here where you break it up into different fractions, the smaller fractions where you have each term in the first bracket being put into its own separate fraction with the second bracket being on the bottom. Okay? And then what you do after that is you put each fraction in lowest terms. Let's try that one more time before you guys get a chance to try it. Okay, so again, what I'm going to do here is I'm going to skip ahead. Okay, you could make it into a fraction like I did here. I showed you that already. But you know that eventually we're going to end up with the different smaller fractions here. And like I said, you're going to take the second bracket with the single term in it, and you're going to distribute that to each term in the first bracket and divide it into each one of those terms. Let's see how that looks. Negative 45x5y4 divided by negative 9x3y2. Remember, that's negative divided by negative. What is negative divided by negative? It is positive. And so I'm going to say positive in front, which means that I don't need to write anything if it's the first fraction. Okay, but don't put a negative in front because we know it's supposed to be positive. Okay, like that. The next one here is, again, negative 27x4y5 divided by negative 9x3y2. Negative divided by negative is positive, so I'll put a plus there. And then write down your two terms. Again, don't put any negative signs inside of the fraction there. Okay, we've already figured out what to do with the negative signs. Okay, we either put a plus or minus in front. Okay, that's all you got to do as far as the net positive and negative signs are concerned. We already took care of that by putting a plus in front, and so don't put any negative signs inside of the fractions. Okay, now, next part here, positive 9, negative 9. So positive divided by negative is negative, and so I'm going to put a minus right there. And then what? Then we have this right here. Again, no negatives on the insides of the fractions. And then finally, positive divided by negative. That's negative again, so we put a minus. And then just put the two terms there, but with no negative signs on the inside of the fraction. Just outside of it here. Okay, and then we put each fraction in lowest terms, just like we did in the last problem. In exactly the same way. 45 and 9. What's that common number that divides into 45 and 9? How about 3? I'm not saying 3 is the only one, but 3 is one that does do it. Okay, if I do that, I get what? I get 15 and 3, right? But is there another common number that divides into those two brand new numbers right there? Yes, 3. So you have to keep on going until the number 1 is the only number that works. 15 divided by 3 is 5. And 3 divided by 3 is 1. Now all I got left is 5 and 1. And 5 and 1, the only common number that you can divide into those is 1. So that means that 5 and 1 are in lowest terms. We then do that thing where we subtract the exponents. 3 is a smaller exponent. Remember, you have to do it with the same letter. You can't combine x5 and y2, for example. It's got to be x and x, and it's got to be y and y. Okay, let's start out with the x. For x, we got 5 and 3, so 3 is a smaller exponent. What happens when I do 5 minus 3 and 3 minus 3? I end up with x to the second, and I end up with x to the 0 down here, which is 1. As you know, anything to the 0 power is 1. Now we do that same thing for the y variable. 4 and 2, the smaller exponent is 2. And so I'm going to say what? I'm going to say 4 minus 2. That gives me y to the second. And 2 minus 2 gives me y to the 0, which is the same thing as the number 1. What am I left with here? 5 times x squared times y squared. On the bottom, I have 1 times 1 times 1, which of course is equal to 1, right? And as you know, if the denominator is equal to positive 1, you don't need to write it. So I just have to write the top. And we're done with the first fraction. Let's go to the next one. What's a common number I could divide into 27 and 9? I could do 3, but I could also do 9. And if you divide by a bigger number, as long as it works, you'll get to the answer more quickly. Okay? I didn't do that on the last one there, just to make a point to remind you that, hey, you could do it in smaller parts by dividing by 3 and then dividing by 3 again. That's okay, and I was just trying to make a point about that. But you could divide by 9 here as well, all right, and get to the answer more quickly. 27 divided by 9 is 3. 9 divided by 9 is 1. And now that's in lowest terms. How about the 4 and the 3 on the x's here? The smaller exponent is 3, and so we're going to do what? We're going to do 4 minus 3 is x to the first up here. Okay, and then 3 minus 3 gives me x to the 0, which is the number 1. And then finally the y part, 5 minus 2 and 2 minus 2. Since 2 is a smaller exponent, I get what? I get y to the third power. And I get y to the 0 power, which is 1. What am I left with? I'm left with 3 times x times y to the third. Bring down that plus as well in front of that. Always bring down the sign in front. Don't forget that. But then we have 3xy to the third divided by 1 times 1 times 1. That means you don't need to write the denominator because it's equal to 1. Bring down the minus, and let's do it a couple more times here. 9 and 9, you can divide both of those by 9. You get 1 and 1. That's already in lowest term, or that is now in lowest terms. How about this, though? What happens when the exponents are the same? We haven't seen that yet. When it's the same, the smaller exponent obviously would also be that same number 3. So if I go 3 minus 3 and 3 minus 3 on both of these, don't I get x0 and x0? Which would mean what? That means that it's going to be 1 and 1. Okay, so when the exponents are the same, it's going to be 1 over 1 every time because you're going to get a 0 exponent in both the top and the bottom. Finally here, the smaller exponent is 2 on the y variable, and so I end up with 5 minus 2 is y to the third, and then 2 minus 2 gives me y to the 0. What do I end up with here? 1 times 1 is 1, times y to the third is y to the third. Remember, that's how you multiply three things together. You multiply two at a time. Okay, 1 times 1 is 1, times y to the third gives me this right here. 1 times 1 times 1 on the bottom, again, you get that same invisible denominator of 1. You don't need to write it. Bring down the minus right there. On the last one, 63 and 9, I could divide both of those by 9, and I get 7 and 1. The exponents are the same on the x's again. And so once again, I'm going to get x0 over x0, which is 1 over 1. Okay. And finally, the smaller exponent here with the y is 2. And so I'm going to get y to the first. 3 minus 2 gives me y to the first. And then 2 minus 2 gives me y to the 0. Okay, sorry, that came off the screen there. Y to the first right there. 3 minus 2. Okay, so we end up with what here? We end up with 7 times 1 is 7. And then 7 times y is 7y. And that's it. So please try right now these next two problems right here. You can see that in both cases they're once again dividing by a single term. It just wrote it in the form of a big fraction instead of using two brackets, but it's the same idea. When you got a one big fraction like that, you are dividing each of the terms on top by the term on the bottom. So you're going to split it up. You're going to split this one up into two fractions, okay, because there's two terms that you're dividing into on top. Okay, just like we had three terms on the top right here, and we ended up with three fractions. Okay, same idea here. You've got three terms on the top, right? Okay, and so you're going to end up with three fractions there. So do the same thing with the two fractions here and the three fractions here, and we'll take a look at those answers in just a moment. All right, so let's go ahead and take a look at number one. Again, we split it up into two parts right there. And if we do our canceling there, okay, 15 and 5 become 3 and 1. Okay, 4, x to the fourth and x to the first. You subtract both of those exponents by 1. We end up with x to the third divided by x to the 0, which is the number 1. y2 and y1, we subtract by 1 there. We get y to the first over y to the 0. And that gives me what here? That gives me 3x to the third y to the first divided by 1. And of course, you don't have to write down the 1. Bring down the minus. Okay, there we go. And then we do our same type of canceling here, and we end up with what? 4, 1, x to the fourth over 1, and y to the third over 1. Okay, so let me make that a little bit darker right there. And that gives me that right there because, again, the denominator is going to end up being 1 again. All right. Let's look at number 2 right here. Again, remember your signs here. Positive divided by negative is going to be negative. And so that's why I put a minus in front right there. Positive divided by negative, again, is going to be a negative on the second one in front. But then negative divided by negative is going to be positive, and so that's why I put a plus in front right there. Okay. Then we do our canceling. You don't need to rewrite an entire step for the canceling, by the way. I just did that so that you could see what answer I got before I started crossing stuff out. Okay, you could do your canceling up here on this line if you want. That's fine. But what I end up getting, doing the same things that we've been doing, is what you see right here. You can see that all three of them end up being fractions. Okay, none of them have a denominator of 1 in this particular case. Okay, this is x squared y right here. Just want to make sure you can see it. Okay, there we go. All right, so that is how number 2 comes out. And so that concludes our discussion on when you divide a polynomial by just a single term. In other words, when the second thing that you're dividing by is just a single term. So what happens when you divide by two terms? Okay, as you can see, for example, on this sample problem I have on the front right here, we're dividing by x minus 2, two terms instead of just one. You cannot do what we did right here. Okay, one of the reasons why you can't do that is because if you were to take x minus 2 and put it underneath all four of these things separately, I'm sorry, that fell off the screen there. Let me say that again. If you take x minus 2 and you put it underneath all four of these terms separately, you wouldn't be able to cancel anything because, as I said a few minutes ago, you can't cancel when you have two terms in the denominator. It's got to be a single term in both the top and the bottom of the fraction. So we got to do things differently here. What are we going to do? We're going to do something you may notice right here. This looks kind of like long division that you may remember from elementary school, maybe middle school, whatever. Okay, wherever it may have been. This is a slight variation of that, but because it's so similar to long division, what I'm going to do right now, just for a moment, is I'm going to refresh your memory of what long division is by doing a problem that doesn't have any variables in it, and then you'll see how it's closely related to the actual method that we're going to use today with the polynomials that include the variables in them. So 86 divided by 3. How do we do long division on that? So we're going to take a visit back to 3rd grade, 4th grade, whatever grade it was that you learned it in. And you always put the first thing that you're dividing inside of the division bar. The second thing goes outside. Then there's three main things that you do, and you do them repeatedly until the problem's done. First thing you do is you divide. Divide what? You divide 3 into the first number if it goes into it at all. 3 does go into 8. How many times? It goes into it twice, because if you put 3, then that would make it 9, and 9 is too big for 8. Okay, so 3 goes into 8 twice. All right. And then what do we do after we divide? We then multiply the 2 times the outside, don't we? That's 6, and then we put it underneath the 8 that we originally divided into. Okay, hopefully this is coming back to you. Let me know if you have any questions. Not that we're going to be doing these specific problems. This is just something that helps refresh our memory for what we're eventually going to be doing today. So if this doesn't all come back to you, don't worry. It's just going to help us get to the method that we need. 8 minus 6, so now we need to subtract. And we get 2. So what three things did we just do? We divided 3 into 8. Then we multiplied 3 times 2. And then we subtracted 8 minus 6. Divide, multiply, subtract. Those three things. And then you do those same three things again after you bring down the 6. So you bring down that next number, okay, and you do the same thing again. 3 does not go into 2. It's too small, but it does go into 26. How many times? It goes into it 8 times because 3 times 8 is 24, but you can't put a 9 there because then that would make it 27, and that would be too big. Okay. Then what do we do after we divide? We multiply, right? 8 times 3 is 24, and then we subtract. And now we're done. There's nothing more to do. And so what you may remember doing is there was 2 different ways that they taught you this at the end of the problem. You either say remainder 2 right here, because 2 is a remainder, or you make it into a mixed number. What we're going to do today is we're going to make it into a mixed number. You take the remainder, you put it on top. You take the thing on the outside, which we call the divisor, and we put that on the bottom. And that's the fraction part of the mixed number. Okay, 28 2/3. Okay. What we're going to be doing today is not completely the same, but it has so many similarities to that. That's why I showed you that example just now. Okay, let's try to get this problem started right here using similar concepts, and then whatever's different, I will point those things out carefully to you. Okay, so don't worry. First thing you need to remember, though, is that when you do one of these problems where you do long division, you have to put both the numerator and denominator in descending order. Remember we talked about descending order in previous sections. Okay, how do I reverse these terms around so that it's still the same polynomial, but it's in descending order? Okay, well, we know that this has to go first, 9v to the fourth, because that's the highest degree term. It's got the exponent 4. That's a bigger exponent than any of them. Okay, so let me do this. I'm going to put this numerator inside of the fraction or inside of the division bar like I always do, just like I did with the 86 a minute ago, because it's the what's on top. What's on top goes on the inside. So I put the 9v to the fourth. You don't need to put the plus in front because it's the first term. But remember, when you reverse terms around, when you reverse them around and put them in a different order, you need to have the same sign in front of each term that you did originally. Okay? But since you don't need to put a plus in front of the first term, you don't need to put that plus there. Again, you can if you want. What would be the next term? It would be 17v to the third. Since that's positive 17v to the third, and since you have to have a plus or a minus in between the terms, not in front of the first one necessarily, but in between, you got to now put a plus in front of that. Okay, so even though it didn't have a plus originally, it needs to now because it's no longer the first term. Then what would go next? Negative 56v squared. Again, just make sure the negative's in front of it because it has to be the correct sign when you change the order. You still have to have the same sign in front of each term. Next, you would have positive 33v. So again, put the plus in front of that because it has to stay positive. And finally, negative 18. Put that minus in front of that to make sure it stays the same sign, negative. And there you go. It is now in descending order, but it's still the same polynomial because you still have the same correct signs in front of each term. Okay. This polynomial on the outside also has to be in descending order, but you can see that it already is. V to the first and then no V at all. That's a degree 1 term, and that's a degree 0 term. And so that would be correct as it's written. Okay, now, what do you do first? What you do first is, just like we were talking about, you divide and then you multiply and then you subtract. But it's a little bit different here with the variables and the polynomials. What you do is you divide the first term inside by the first term on the outside. Let me write that up here. Let me make some room up here. I'll put 9v to the fourth divided by 9v. It's got to be the inside on top and the outside on the bottom. And then we just put this fraction in lowest terms just the same way we did earlier in this section. Okay, and that'll work just fine. So we get 1 and 1 for the 9s. And we get v to the fourth, and v becomes what? It becomes v to the third over 1. Okay, and so if we put that all together, we get 1 times v to the third is v to the third. 1 times 1 on the bottom is 1. Again, you don't need to write the 1 on the bottom. Okay, and so we end up with v to the third. Just like I did in the previous long division problem I showed you, take the answer that you get to the division and you put it on the top. I don't care where you put it. It really doesn't matter. Just kind of put it far enough over here that you'll have enough room to write some more stuff after that, okay? And that'll be fine. What did we do after we divided, though? We multiplied, right? But what do we multiply by this time in this particular problem? What we do is we multiply by the entire outside, not just the first term this time, but by the entire outside. That's just how it works. With the division, you just do the first term, but when you multiply by the entire outside part. Remember what I said in the last section, 6.3. I said that when you need to multiply by something that has 2 terms in it, and you're supposed to multiply by the whole thing, you got to put a bracket around those 2 terms that you're multiplying by. And then that reminds us to distribute it, which is exactly what I'm going to do. Because when you have a term times a bracket, you got to distribute to each term on the inside, don't you? You get what? You get 9v to the fourth minus v to the third. So here's what you do. You take that, just like we did in the other long division problem. You take that and you put it underneath. Whatever you get when you multiply, you put it underneath. Let me fix that right there. That's v to the fourth. Okay, and then what did we do after that? We need to subtract, right? But here's the problem, though. I need to subtract this entire first polynomial minus this entire one. The textbook, if you're looking at that, it teaches it a little bit differently, but it doesn't always work the way they teach. It works most of the time, but not all the time. There's sometimes you run into some problems. So I like to teach it as you're subtracting this entire line minus this entire line. That's something different than this problem right here where you didn't do 86 minus 6, you did just 8 minus 6. But here, you're doing the entire first line minus the entire second line, okay? But that reminds us of something that we learned all the way back at the first section, section 6.2. We learned that when you subtract an entire polynomial times an entire other polynomial, you have to what? You have to change the signs. It's kind of like this. Let me go back to that for just a moment here. Okay. When you have, I know there's no brackets in the current problem we're working on, but it's similar to this where you have an entire polynomial times an entire other polynomial. What did we do? We changed it to a plus problem by changing the signs of all of the terms in the what? All of the terms in the second polynomial. Okay, in the second bracket. Well, a similar thing happens here. Since we're subtracting, we change all of the signs in the second line. This line of terms here. This line stays the same. This one you change the signs. So this becomes negative 9 on the second line and plus 1 v to the third. Instead of minus 1, it's now plus 1. The 1 is invisible. Once you change those signs, then just like we did in 6.2, we just then combine like terms after that. Same thing. So you change the signs of just the second line only, all the terms in the second line, and then you combine like terms. What do we get? Well, these terms are going to cancel when you combine like terms, aren't they? They're going to be equal to 0. That first column, you guys, should always cancel when you're doing long division, every single time. If it doesn't, okay, stop what you're doing because you did something wrong. Okay. Now let's combine like terms on everything else. We get 18v to the third. And then these other three terms don't have any like term partners to go with them. And so they just go on down like we talked about before. They just go right on into the answer here. They just get added and subtracted to what's already there. And that is the subtraction step. So we've divided, we've multiplied, we've subtracted. So now we have to start that process all over again. Since all of the terms have already been brought down, you don't need to bring down the next term like we did in the other long division problem we looked at. You just need to take what you got and start all over again and do the same thing we did at the very beginning of the problem. Okay, you just go through that process again. What was that process? You take the first term down here and you divide it by the first term out here. Just like we did with 9v to the fourth, you now do that with 18v to the third. 18v to the third divided by 9v. What is that equal to? Put it in lowest terms and you'll find out. Okay? So 18 and 9, that reduces down to 2 over 1. V to the third and v, that reduces down to v to the second over 1. Again, doing it the same way we've been doing it. And we end up with 2v to the second. 2v to the second. So what do I do with that? Just like I always do when I divide, I take the answer, I put it on the top here. But here's the thing. If it's not the first term that you put on the top, you got to either put a plus or minus in front of it. Okay? You got to either add it or subtract it to what's already there, depending on that sign. Since it's positive, I'm going to add it. If it had been negative, I would say minus. Okay? But you got to put that there. You can't just put the 2v squared. Okay? And now what did we do after we divided in the last part, or in the first part of the problem? We then multiplied. So you take the answer you got when you divided, just like I did with v to the third. You do the same thing with 2v squared. You take that and you multiply it by the entire outside of the division bar, 9v minus 1. And what do we get? We get 18v to the third. I'm distributing here. 18v to the third minus 2v to the second. Like that. Let me write that down. And what was that thing that we talked about that you got to do now that you're on the subtraction step? You have to what? You have to change the signs of the second line only. Just like you changed the signs of the second bracket only when we were doing the subtraction problems back in 6.2. Second line only. So I changed this to negative 18 right here on the second line. I changed this to plus 2. All right. But I keep the first line the same. But what do I do after I change those signs? Just like in 6.2, I combine like terms now. And as always, the first column should cancel. Don't just assume it cancels. Double check to make sure it does, because if it doesn't, that means you made a calculation mistake. So you want to be able to fix that. It does cancel, though, so we're fine. If I now combine like terms on everything else, I get negative 54v squared. And then these other two terms don't cancel with anything. Okay. And then we go through the process again. I'll tell you when we're done, okay? It won't be too much longer, but we got a little bit of a ways to go. This is not a very short problem, to be honest with you, okay? It's one of the longer problems we're going to do. So now we do the same process again. We take the first term and the first term again. First term divided by first term. Just like I did with 18v to the third, I now do it with the first term here. What do we get? If I put that in lowest terms, I'm going to get negative 6 and v to the first. Okay? Negative 6, when you cancel those, you don't have to write down the cancelings if you don't want to. Okay, that's just to help you. All right? But it does make it easier. Just to save time here, I'll just mention that that's negative 6 over 1 and v over 1. Okay. What do I do with the answer that I get when I divide? I put it on top. If it's negative, just put that minus in front and you'll be fine. Okay. If it had been positive like it was here, then you put the plus in front, as we talked about. Then what do I do with that? I take that whole thing, not just the 6v, but I take the entire term, including the negative, and I multiply that by the outside, the entire outside. Put a bracket around 9v minus 1 again. And then I distribute, and I get negative 54v squared plus 6v. Okay. Bring that down. But what do I got to do before I combine like terms, you guys? Since this is a subtraction step, I need to change the signs of the second line. The second line. And so this becomes a plus. Pull out your eraser right here and change this plus in front of the 6 to a minus. And we get combining like terms, the first column cancels again as it should. And we get 27v minus 18. Okay, now you might be starting to wonder, oh my goodness, when is this ever going to end? Okay, there's one more step to go, and you'll see why in a minute here. Okay, but let me go ahead and do it, and then I'll show you why I know that it's done after that. Okay, again, first term divided by first term. 27v divided by 9v. What do we get? Remember, the v is the same exponent, v to the first and v to the first. So that's going to be 1 and 1 here. Okay. And then 27 and 9 are going to become 3 and 1, aren't they? Okay. So we get 3 times 1 and 1 times 1. What is that? That's 3 over 1, isn't it? Which is positive 3. What do we do with the answer when we divide? We put it on the top, and if it's positive, we need to put a plus in front of it, don't we? Unless it's the first term, then you don't have to. Okay, then we take the answer that we get for the division, and as always, we take that and we multiply it by the outside, put a bracket around the outside, distribute it out. There you get that answer right there, and we take that and we, just like we've been doing, we bring it down to the bottom of the problem, and now we're ready for the subtraction step. Again, what does the subtraction step tell us? It tells us to change the signs of just the second line only and then combine like terms. What do we get? We get the first column cancels as it should, and it does. And then we get negative 15, and that's it. Why are we done? Okay, we are done because The divisor here, the thing on the outside, what is the degree of that polynomial? Remember, degree of a polynomial is when you figure out the largest degree of any of the terms. This is a degree 1 term because it's v to the first. This is a degree 0 term because it's got no variable. So this is we take the highest degree is the degree of the whole thing. Since it's degree 1 and degree 0, it's going to be degree 1. Here's how it works. The remainder, which is the thing that you get immediately below the line right here. We got a bunch of lines here, don't we? Okay, every answer that you got right directly below the line is a polynomial. This one right here was degree 3 because the highest exponent was 3 there. This one was degree 2 because the highest degree was 2, as you can see there with v squared. This one was degree 1. Okay, you can't stop this problem until the degree of the remainder, which is the thing that's immediately below the line, not until that thing is a smaller degree than the degree of this thing out here on the outside of the division bar. Okay, since this right here is degree 0, we can now stop because it's a smaller degree than degree 1. But you can't stop until it is smaller degree. So what do? You take that answer just like I did with the mixed number thing earlier, and I say plus, and yes, you got to put that plus there. I'll explain that in a minute. I know we don't do that normally with mixed numbers, but you got to do that here. And then we say the remainder, negative 15, over 9v minus 1. Let me make some room for that. There we go. So you can see that better. Okay. And there you go. Yes, you got to put that plus there, okay, because you're not allowed to do mixed numbers officially with variables. You're not allowed to make a mixed number when you've got variables normally. And so by putting that plus there, it's not really a mixed number, but it is equivalent to it, okay? So that's what you do. You write down the plus, and then you take the number at the bottom, or the term, whatever it may be, put that in the top there, just like we did in the 86 divided by 3 problem. Okay, you take that and put it on the top. Okay, just like I did here with the 2. Okay, and then the outside part goes on the bottom. So I did that with the 9v minus 1. Okay, can you change this to minus positive 15? Yes, you can. You could say minus here just so long as you change this to positive 15. That's okay to do that. You don't have to. So if you're not sure about it, don't do it. But yes, you can do that. I know some of you are probably thinking that right now. Okay, but you can only do that if there's a single term up here. You can't take the minus 1 and move that out into the front and make this a minus. You can't do that because there's 2 terms down here. But if it's just a single term, you can take the minus and make this, you can take the negative here and you can make that into a minus and say minus positive 15, and then this would stay the same. If you write that as your answer, it will be perfectly fine. Don't worry. Okay. All right. Now, a lot of stuff happened there, so it'd be a good idea if we practice this again, huh? All right, so again, we need to put our polynomials in descending order when we do long division. Okay, we do that. And so how is that going to be written? The 15y to the third would have to go first since it's positive. We got a positive in front of the 15. Don't need to write that if you don't want to because it's positive. 16y squared, since that's positive, I do need to put a plus in front of that since it's no longer the first term, it's now the second term. 13y is next. Again, put a plus in front of that because it's positive. Okay, and then finally positive 6, put a plus in front of that because it's positive. And now it's in descending order. The 3y plus 2 is already in descending order, so no need to change the order of that. And let's go ahead and get started here. All right. So what do? We need to do the first term divided by the first term, just like we did in the last problem. That's the division part. And we get what here? We get 5 over 1 and y squared over 1. Okay, when we put that in lowest terms. So we get 5y squared over 1, which is the same thing as just what? 5y squared. You take the answer that you get from the division part and you put it on top. And then you take the answer from the division part, and not only do you put it on top, but now you multiply it by the outside part. We did that a number of times in the last problem, didn't we? We distribute that out, and we get 15y to the third plus 10y squared. Okay, and what do we do after we multiply? We take that answer and we put it underneath what we already got, like this. But what's that very important thing I have to do next, since it's now the subtraction step? I now need to change the signs of just the second line, right? So that becomes minus 15 on the second line and minus 10. If I then combine like terms, I get, as always, this should cancel, and it does. It's equal to 0 if I combine those. 0, y to the third, which is the same thing as 0. And then this is going to be 6y squared. And then the other two terms don't combine, so we just bring them down behind what we already have in the answer there, 13y and 6. And then we start all over again by dividing, right? We take the first term here and the first term there. Make sure you're writing your answers in descending order underneath the line also. That's important because the first term needs to be the highest degree term in order to make this work correctly, and it wouldn't be if you didn't put it in descending order. So just make sure it's in descending order, okay? As you can see, it is. Y to the second, y to the first, and then no y at all, descending order. 6y squared divided by 3y. First term divided by first term. What do we get? That reduces down to 2 over 1 and y over 1. 2 over 1 and y over 1, and that's why it's going to be 2y over 1. So I take the 2y, and I don't just write 2y up here, do I? If it's positive, what do I need to do? I need to put a plus in front of that, just like I did with the 2v squared and the 3 here, since those terms are supposed to be positive answers. Same thing here. Then I take what? Then I take my 2y, and I multiply by the outside part, and I get 6y squared plus 4y. Okay. But remember, before you do anything else, you need to what? Because we're now on the subtraction step, you change the signs of each term in the second line. This causes the first column to cancel, okay, as it always should. And then we get what? We get 9y plus 6. 9y plus 6 when we combine like terms right there. And so we're now back to having to do the division again. Are we done, though? Can we stop? No, we can't, because this is what? This polynomial that we get underneath this line is a degree 1 polynomial, isn't it? And that's the same as this one. You can't stop until the answer you get underneath the line is a smaller degree than the degree of the divisor outside of the division bar here on the left. Right now it's the same degree, so that probably means that we're going to need to do one more round of dividing here. We'll see, but it looks like it's going to be that way. We'll find out. 9y, first term divided by first term here. 9y divided by 3y. We're going to get 9 and 3 reduced down to 3 over 1. And then y and y reduced down to 1 over 1. Okay, and so that's just going to end up being 3 times 1 on the top and 1 times 1 on the bottom, which is going to just be equal to 3 over 1, isn't it? Since that's positive 3, I'm going to say plus 3 on the top. And then something interesting happens here, but let's go through it. Let's go through the normal thing here first. 3 times the outside part here, again, put it in brackets. And what do we get when I distribute that out? 9y plus 6. So I bring that down, but I need to change the signs of the second line before I combine like terms. Okay, so this becomes negative 9 and negative 6 on the second line. What happens, though, when I combine like terms right now? I don't think we've seen this happen before, but this is the first time that when we've combined like terms that all of the terms end up canceling out. All of the terms, when they combine, end up being equal to 0. And remember, you guys, when you combine like terms, the answers that you're supposed to get when you combine like terms are supposed to be added and subtracted together. So if all of the combining like terms just ends up being equal to 0, what do you get? Well, what happens if you do 0 plus 0 or 0 minus 0? Okay, it ends up being equal to 0 either way. The whole thing, in other words, is equal to 0. So my point is that if you combine like terms and all the terms cancel out, if all the terms end up being equal to 0 when you combine them, the whole answer then is going to be 0. What happens when you do long division, you guys, and you have a remainder of 0? Which and this is the final remainder, by the way. This is not one of those remainders where we still had to do another step. It's the final remainder because this is a smaller degree than the degree up here, right? So we know that we're done. We don't have to do another division step, okay? But what happens when the final remainder is 0? Not just a number like negative 15, but it's 0, okay? That means that we do not have the fraction part. You may remember from doing those mixed number problems in the past, like these, if you ended up with a 0 down here instead of a 2, okay, you don't do the fraction part. You just take what's already up there and you leave it that way. So if this had been a 0 right here, you guys, the answer would have just been 28 only. Okay, it's because it wasn't 0 that you had to do the fraction. So because this is 0, you guys, just take what's already up there, and that's your answer. No fraction when the final remainder is 0. Okay? And so that's what happens when you get a final remainder of 0. Please try right now problems 3 and 4. They are very similar. Okay? You can see that all the polynomials are already in descending order for you. You don't need to do any changing of the order in this case. But go ahead and try those two problems, and we'll take a look at those answers in just a moment after you hit play. Okay, let's take a look at number 3. Again, the terms are already in the correct order, so I'm going to take the first term divided by the first term. You see I did that over here. I ended up with 6y. So I put the 6y first up here on the top. And then I take that answer and I multiply that by the outside part with the bracket like we talked about. We get this answer down here. I put that underneath. Okay. Originally, it was positive 12 and positive 6. The reason why you see the minuses there is because, remember, after you put it down there, you need to change the signs, okay, before you combine like terms, and that's why you see the 12y squared and the negative 12y squared and the negative 6y. After I combine like terms, I get this right here. So now what do I need to do? I need to take 14y, the first term, divided by the first term here. You can see I did that over here. And I end up with 7. The y's cancel completely. We get 1 over 1 because the exponents are the same. So I take the positive 7, I put that up here. Okay. Remember to put the plus in front if it's positive. Multiply that answer now by the outside part. We end up getting, there we go. We end up getting 14y plus 7. So I'm going to take 14y plus 7. I'm going to put it underneath what I already had there. But after I do that, I need to change the signs of both of those two answers, 14y and 7. Okay, since it's on the second line. I then combine the like terms. This column will cancel. Okay, and we'll end up with negative 2 only with no y terms there because they cancel. This is a degree 0 term because there's no variable in it. This is a degree 1 polynomial, okay, because it's got the y to the first, and that's the highest degree in that polynomial. So degree 1, this is degree 0, so we're done because this is a smaller degree. So I take that remainder, that final remainder, I put it up here, put the plus in front of it like we talked about, okay. You got to put the plus before you put that fraction there on the last part of the long division problem. Okay, Yes, you could change it in a minute here. I'll talk about that. But normally you put the plus and then you put the remainder on top and then this thing on the outside here underneath it. Yes, because negative 2 is a single term, you could change this to minus on the outside and then positive 2 right here. You don't have to, though, if you're not comfortable with that. But you can. But don't do it unless you're sure you know what you're doing. Okay. Number 4. Number 4, again, everything's in the right order, so I go ahead and jump right into it. Okay, 12t to the third divided by 4t, first term divided by first term. Okay, I get 3t squared out of that. I then take the 3t squared and I multiply that by what? I multiply that by the entire outside part. That gives me what? That gives me 12t to the third plus 9t squared. But when I move it down underneath, okay, I then need to change the signs of those answers after I move it underneath here. That's why it is now minus minus. The first column will then cancel when you combine like terms, and you end up with this now underneath the big line right here. Okay, this right here. So then I go through the process again. Negative 20t squared divided by 4t. That's going to end up being equal to negative 5t. That's where this came from right here. So then I take negative 5t, and I'm going to multiply that by 4t plus 3 on the outside, and I get what here? I get negative 20t squared minus 15t. Notice that both of those are negative. And so when it goes down underneath here, I need to change both of those to positive because they both need to change the sign on the second line. That's why this now says positive, positive right here. Positive 20, positive 15. Then I need to combine like terms now that the second line has been changed with its signs. And I end up getting the first column canceling again. And then I get 24t and 18. This is a degree 1 polynomial because it has t to the first in it, and that's the highest degree term. Okay, this is a degree 1 term, and this is a degree 0 term. So the whole thing is degree 1 because you pick the highest degree to figure out the degree of the whole thing. This is all important because we know then that we're not done yet because the degree of this polynomial on the outside over here is also degree 1 because of the t to the first right here. So we got to go at least one more step here. All right. 4t and 24t, I divide those, and that's where I get the positive 6 right here. I then do what? I then take the 6 and I multiply it by the outside part right here, and I get 24t plus 18. 24t plus 18. But then I need to change the signs of both of those since it's the second line. Okay, I did that. I then combine like terms, and just like it was in problem D right above this here, okay, everything cancels. All right, and when everything cancels, when you're combining like terms, the answer is always 0. Okay. It's not like when you have a fraction, okay, where everything cancels. Okay, that's different. Okay, everything cancels on the top and the bottom. But when you're combining like terms and everything cancels, as we talked about canceling, you know, when the terms are equal to 0, okay, this is equal to 0, this is equal to 0, okay, then the whole thing is equal to 0. And what do we say when the remainder is 0? And it's just 0, no variable or anything, just 0, okay, then you do not put the fraction up here, right? You just take what's already there, okay, and that is your final answer. Okay, just like it was in problem D. Okay, so that concludes section 6.4, dividing polynomials. Again, please remember that when you divide by a single term, it's a completely different method than when you divide by two terms. Okay, very important for when you're studying for the exam and all that. Okay, so you have a good day, and we'll see you back actually for the beginning of chapter 2 in the next video.